This is the third part of our problem, which was given a set of data about the hours a day per day. 11 patients suffered from headaches before and after 7-week soft tissue therapy. At alpha at 0.01, is there enough evidence to conclude that soft tissue therapy helps to reduce the length of time the patients suffer from headaches? Complete, I believe it would be all 6 parts of this. And we're on the third part, which is calculating the mean of the differences. We can call that, they call it D bar. Sometimes you see this mu sub D. And this is the mean of differences. And S sub D will be the standard deviation of differences. It's what matters, and it's not, well, you have pairs of data, really what matters is the difference between in each pair. In the data we have, I've calculated the differences for you, and they are these D's, 0.05, 1.6, 1.1, 0.9, 0.4, 1.1, 1.1, 1.5, 0.6, 1.9, 0.8. So when we subtract and make find the difference in each pair, this is what we get. So this is the data we're going to use to calculate the mean of these and the standard deviation of these. And the, of course, D bar, which is the mean, is simply the sum of all these differences divided by the number of them we have. Add all these up, you get, what is that, 11.5. N is 11, there are 11 pairs of data. 11.5 divided by 11 is 1.0, approximately 4 or 5. So that's the difference, that's the mean of our differences. Now we need the standard deviation of our differences. Let's see. There's 2 formulas we could use for this. We could say, well, S sub D is square root of the sum of these differences, D minus D bar, squared, all divided by N minus 1. Or the formula that looks worse but is easier, or it's quicker to compute. The sum of the differences squared minus, let's see, the square of the sum of the differences divided by N divided by N minus 1. This is uglier, but if we're working it out without some kind of technology, it's easier to do. So we'll use the second for that. So we take those differences we had and we square each one of them and add them up. And the sum of all those differences that we squared is 14.27. So with that, we just compute S sub D, which will look like this. 14.27 minus 11.5 squared divided by 11 over N minus 1, which is 11 minus 1. Compute that, you're going to get 0.474. Now I notice a lot of the problems students have with these things they get all the way to here just fine, and they understand how to do the problem, but then they put this in their calculator wrong. So sometimes with this type of problem, when it's really messy like this, I like to use Excel because it's easier for me to see the whole problem. So just to show you what it would look like in Excel, you'd go to a blank cell and you would type in equals, And let's see, the numerator of this fraction is 14.27 minus, parenthesis, now this little fraction I have to do inside here, 11.5 squared, and we divide that by 11. Okay, that's this little fraction. So I have 14.27 minus that little fraction there. That's my whole numerator. So I like to keep that together. And then my denominator, divide that by 11 minus 1. Like that. And I keep my denominator in parentheses. And then I put the whole thing in parentheses to take the square root. And I think the easiest way to do that in Excel is just to raise it to the 1/2 power or the 0.5 power. So you raise that to the 0.5 power, and you'll see that you get this. So it's easier to kind of build it in Excel. Your TI-83 type calculators work a similar way. It would look pretty much like this. But a lot of those other calculators, you can't see everything you're typing, and it becomes very confusing. And I noticed that the majority of students miss these problems because of calculator issues. So if you need to, use Excel.